In section 3.2, we will study operations and composition of functions. You're most definitely familiar with how to add, subtract, multiply, and divide real numbers. In section 3.2.1, we will learn how to apply those 4 basic operations to functions. The title of this subsection is Arithmetic Operations on Functions. The word you see here is arithmetic whenever you use it as a noun, but if you use it as an adjective, you pronounce it arithmetic. So we're studying arithmetic arithmetic operations on functions, or how to add, subtract, multiply, and divide functions. So we're going to assume that we have 2 basic functions named f of x and g of x. To find the sum of 2 functions, we denote this f plus g of x. The names of the function are f and g, so this is a concise way of expressing the sum. In practice, we will want to separate this into the 2 individual functions. This means f of x plus g of x. The difference of 2 functions is denoted f minus g of x. We will expand this as the function f of x minus the function g of x. Now, on this particular operation, if your second function has more than one term, be sure to enclose that in a set of parentheses so that you correctly distribute the negative. The third operation we will study is the product, denoted f times g of x. We will evaluate this as f of x times g of x. And again, if either of your functions has more than one term, we will want to include both of those in a set of parentheses so we can correctly evaluate the order of operations. The last basic operation we will denote is the quotient of 2 functions. Notice the operation is always expressed between the function names. In the case of the quotient, we have f divided by g of x. We write this concisely and efficiently. However, in practice, we will expand it into 2 individual functions, f of x divided by g of x. Now, the quotient will also have something to pay attention to. The quotient only exists provided the denominator g of x does not have the value of 0. If g of x equals 0, then we have an undefined function. In this section, we're going to consider 2 versions of these operations. We're going to add, subtract, multiply, and divide functions that have a number in the argument position. And then, in example 2, we'll look at the more general application of having a variable in the argument position. So let's get to know these operations with the number in the argument position. So in example 1, we have 2 functions, f of x equals x squared plus 3, and g of x equals negative 2x plus 6. Now, just based on what you know about equations, if I asked you to classify f of x and tell me what kind of function is it, would you know what to say? This is a quadratic function. We studied quadratic equations in one variable. Now we're looking at a quadratic function. How about g of x? If I asked you to classify this function, what would you tell me? Hopefully you'll recognize that is a linear function. We studied linear equations in 1 and 2 variables. Here we have it expressed as a linear function. Okay, let's get back down to our problem. We want to first evaluate f plus g of 1. So that is our concise shorthand notation. To evaluate it, we're going to expand it in terms of the 2 functions. This is going to be evaluated as f of 1 plus g of 1. Now, we have learned how to evaluate a function. In this problem, we're just evaluating 2 functions in one problem. We just have to know how to read the instructions here. The first part says, use the function called f. So I'm going to go to the function called f, and I'm going to plug in 1 for x. So this is going to give me 1 squared plus 3. I'm just plugging 1 in for x there. Then I'm going to add this to g of 1. G of 1 is telling me use the function called g, so now I know I'm going to use this function rule, and I'm going to plug 1 in for the argument, or I'm going to put a 1 right there. So we have negative 2 times 1 plus 6. So essentially, we're just evaluating two functions in one problem and summing their outputs. F of 1 is 1 squared plus 3, or 4. Over here, we have negative 2 plus 6, or 4. So f of 1 plus g of 1 gives us 8. So we evaluate each function and then sum the results. In example B, we have f times g of 3. We're going to evaluate this as f of negative 3 times g of negative 3. Again, the function names f and g point to which rule I should use. To find f of negative 3, I'm going to go to the function called f, and I'm going to use that function rule, plugging in negative 3 for x. So we have negative 3 squared plus 3. Then we're going to multiply this result by g of negative 3. So I know on this problem I'm using the other function rule called g, and we're plugging in negative 3 for x. The only problem with this is that each function has more than one term. So I want to make sure and include those entire operations in a set of parentheses. This will allow me to evaluate using the correct order of operations. Inside parentheses here, we have 9 plus 3, and inside parentheses here, we have 6 plus 6. Evaluating, it looks like we have 12 times 12, or 144. So think of this as two problems in one. You're evaluating two functions and then carrying out a specific operation. Let's try f minus g of 4. First, we break it down into the two individual functions, f of 4 minus g of 4. Then we're going to use the function rule f, that is the rule x squared plus 3, and we plug 4 in for x to get 4 squared plus 3. Next, I'm going to subtract g of 4. So again, those are encoded instructions, and it's telling me use the function g of x, which is negative 2x plus 6, and plug 4 in for x. So we have negative 2 times 4 plus 6. However, since I'm subtracting more than one term, I have to be very careful to get that second operation, that second evaluation in a set of parentheses. From here on out, we obey the order of operations. We're going to evaluate parentheses and exponents first. And then we can add and subtract left to right. Minus negative 2 here is the same thing as plus 2, so our result is 21. Okay, next we're going to do f divided by g of 0. Anytime you're evaluating an operation on functions, the first step is to divide it into the two individual functions. This means we're going to evaluate f of 0 divided by g of 0. Now, you may have a little alarm bell going off in your mind because you see that 0 in the denominator. If you are reminded of the stipulation we wrote with the quotient, then that's awesome. However, it's not going to restrict us in this case. Notice we said provided that the denominator is not equal to 0. Let's see what happens when we plug 0 into these two functions. F of 0 evaluates as 0 squared plus 3, and g of 0 is negative 2 times 0 plus 6. When I plug these values in and evaluate, in the numerator, we end up with 3, and in the denominator, we end up with 6. Notice the denominator is not equal to 0. Therefore, this is a legal operation. So it's okay to have an input of 0, right? But if I were to plug in a number and get out a 0, then I would have to say undefined. Let's try the next example. F divided by g of 3. First, we're going to break it down into f of 3 divided by g of 3. Now, remember, f of x was x squared plus 3. So when we plug in 3 for x, we get 3 squared plus 3. Now we're going to divide by g of 3. Remember, g was negative 2x plus 6. So we're evaluating negative 2 times 3 plus 6. In the numerator, we have 9 plus 3. In the denominator, oh, we got trouble, right? This gives us 12 divided by 0. Whereas over here on the previous example, we said it's okay to have an input of 3 as long as the output is non-zero. Over here, we weren't plugging in a 0, but we got out a 0. The value of our denominator here is 0. Therefore, this is an undefined operation. If I tried to type in 12 divided by 0 on my calculator would say no can do. 12 divided by 0 is an error. Divide by 0. Okay, so watch for that. You can plug in any number as long as the output is not 0. Let's try one more for practice to make sure we understand the notation. We have f of x equals the square root of x minus 2 and g of x equals x plus 6. If you want to pause the video and try to work this one on your own and then turn it back on to see if you got the right answer, might be a good checkpoint. To evaluate f divided by g of 11, we're going to find f of 11 divided by g of 11. So f of x is square root of x plus 2, so I'm going to use this first function rule in the numerator, and I'm plugging in 11 in for x. And g of 11 in the denominator is this function rule, so we're going to plug 11 in for x there, so we get 11 plus 6. In the numerator, 11 minus 2 is 9. In the denominator, we have a 17, so the output should be 3/17. Okay, so that was adding, subtracting, multiplying, and dividing functions and evaluating them at a numerical argument. In example 2, we're going to look at the more general case, adding, subtracting, multiplying, and dividing functions that have a variable in the argument. This is simply going to feel like combining like terms, doing FOIL, that sort of thing. Let's go ahead and expand m plus n of x into two individual functions. We have m of x plus n of x. Now, m of x is given by this function rule. M of x is equal to negative 5x minus 3. Notice that m of x is equivalent to this expression. So what I want to do is completely replace the function name, m of x, with its corresponding function rule, negative 5x minus 3. Okay, so I have replaced the m of x. I have replaced this with its equivalent. Next, we are going to add this to n of x. So we're going to copy down this plus. We're going to add this to n of x. N of x is equivalent to x minus 2. So I'm going to take my x minus 2 and replace the function name. So we end up with plus x minus 2. Now that everything has been plugged in, we simply combine like terms. We have negative 5x plus x, which is negative 4x, negative 3 minus 2, which is negative 5. So we simply added those two function rules together. Let's practice that with subtraction. We have m minus n of x. This means m of x minus n of x. M of x gets completely replaced with its function rule, that is negative 5x minus 3, and I'm going to subtract the function rule for n of x, which is x minus 2. However, because I'm subtracting more than one term, we're going to need parentheses around that second function, so that on the next step, we will correctly distribute the negative. Without the parentheses, I would have only subtracted the first term of n of x. With the parentheses, I'm subtracting both terms of n of x. When we combine like terms, we end up with negative 6x minus 1. Okay, so remember, we are simply adding and subtracting these functions and simplifying. We are not solving for anything. We're not setting anything equal to 0. We're not isolating x. We plug in the function rules and simplify. The next example is m times n of x. This means the function m of x times the function n of x. M of x is the function negative 5x minus 3, and n of x is the function x minus 2. Notice I put parentheses around each function so that we multiply correctly. This indicates we need to FOIL. So the product of our first two terms is negative 5x squared, outside terms plus 10x, inside minus 3x, and last plus 6. Combining our middle terms, we have negative 5x squared plus 7x plus 6. Notice we started out with two linear functions. M of x is a linear function, n of x is a linear function. When we multiplied two linear functions together, what type of a function did we end up with? We ended up with a quadratic function. So the same way that we classified equations in one variable, we're going to classify functions. Let's try m divided by n of x. Remember, the first step is always to break this down into the two individual functions, each receiving its own argument. Then I'm going to replace m of x with its function rule, negative 5x minus 3, and n of x with its function rule, x minus 2. At this point, there's nothing to reduce or simplify, so that's it. You just stack them up and you're done. So how many of you prefer Unit 3 over Unit 2? Are you finding that Unit 3 is a little easier? Perhaps. Some students feel that Unit 2 is very detailed and complicated and sort of feel better when we get to Unit 3. However, others will say, oh my goodness, Unit 3, we have two dimensions. We've got x and we've got y. It just kind of depends on what you enjoy. So I hope that this is going well for you. Let's do one more example for this video. Let p of x equal negative x plus 4 and q of x equal 2x squared plus x minus 5. What kind of function is p of x? This is a linear function. And what kind of a function is q of x? Because of the x squared, this is a quadratic function. Now, we are going to find p times q of x. We're finding the product of two functions. If you want to pause the video and work through that, and then turn it back on and double check your work with me, that would be a good thing to do. So to evaluate p times q of x, remember p and q are the function names. X is the argument or the variable of the function. We're going to evaluate p of x times q of x. And remember, when you find the product of functions, you often have to use parentheses. So first, I'm going to find the function p of x, and I'm going to completely replace the function name with the function rule. So p of x gets replaced with negative x plus 4. Now I'm going to keep that in parentheses so that I can correctly multiply it by q of x. Next, I'm going to find the function called q of x and completely replace the function name with the function rule, 2x squared plus x minus 5. Okay, now we just have to multiply. We have the case of a binomial times a trinomial. So to do this, we're going to first distribute this first term to every term in the trinomial. So negative x times 2x squared gives us negative 2x cubed. Negative x times x is negative x squared, and negative x times negative 5 is plus 5x. Once that one is distributed, then we will go ahead and distribute the second term into the trinomial. 4 times 2x squared is 8x squared. 4 times x is 4x, and 4 times negative 5 is negative 20. To finish, we will combine like terms and make sure we write this in descending order. That means we're going to start with our highest powered term first, 2x cubed. Then we will combine our x squared terms, negative x squared plus 8x squared is plus 7x squared. We'll combine our x terms. 5x plus 4x gives us 9x, and then we can tack the constant there on the end. So we could say the product of a linear function and a quadratic function is a cubic function. So in this video, we were looking at adding, subtracting, multiplying, and dividing, the 4 basic operations applied to functions. And we learned how to do that with a number as the argument and a variable as the argument.